The Gram stain is the most widely employed staining method in microbiology. It is a differential stain because it divides bacteria into two classes, Gram-positive and Gram-negative. In the first step of the Gram stain procedure, cells from a fresh culture are transferred to a clean slide and allowed to dry. If the cells are on an agar plate, they should first be transferred to a liquid medium for dilution. The cells should form a thin, barely visible film. This can be achieved by smearing cells obtained from the surface of an agar medium or from a liquid culture. Fresh cultures must be used because as cells age, they lose their ability to retain the stain. The cells are then fixed to the slide by passing slightly above the flame of a Bunsen burner. After passing above the flame, the slide should feel warm when touched to the back of the hand, but should not be too hot. The fixed cells are then stained with the basic dye, crystal violet, for 30 to 40 seconds. The slide is then rinsed with water to remove excess stain. At this point, all cells appear purple under the microscope. Next, a solution of Gram's iodine is added and retained on the slide for about 1 minute. The iodine combines with the crystal violet to form a di-iodine complex, thereby decreasing its solubility within the cell. At this point, the cells still appear purple. The cells are then decolorized by washing with ethanol or acetone. This is the differential step. Gram-positive bacteria retain the crystal violet, whereas Gram-negative bacteria do not. The ethanol or acetone should be added drop-wise, with the slide tilted at an angle, until the drop coming off the edge of the slide just starts to become colorless. Even Gram-positive cells can lose the crystal violet iodine complex during prolonged excessive decoloration. Excess ethanol is then washed off with water. When viewed under the microscope, Gram-positive cells appear purple and Gram-negative cells are colorless. Finally, the rinsed cells are covered with the counterstain safranin for 20 to 30 seconds. This stains the Gram-negative bacteria pink. After rinsing with water, the slide is dried with filter paper. When viewed microscopically, the Gram-positive bacteria are purple and the Gram-negative bacteria are pink. Generally, the Gram stain correlates with the cell wall structure among the bacteria. The ethanol is thought to shrink the thick peptidoglycan in Gram-positive cells, thus retaining the dye. The thick, dehydrated peptidoglycan layer of Gram-positive bacteria appears to be a permeability barrier, preventing the loss of the crystal violet iodine complex. In contrast, the peptidoglycan in Gram-negative bacteria is very thin and has large pores. Ethanol may extract lipids and increase the porosity, thus removing the crystal violet iodine complex.